So hello, everyone. My name is Michael Yuan, and I'm the maintainer of the WasmEdge project. So WasmEdge is a WebAssembly runtime at CNCF. And, but here, instead of giving me another talk about what is WebAssembly, I want to talk about one of the biggest use case of WebAssembly that we have seen. In particular, it's in Gen AI. So at current times, we have community users using WasmEdge to run large language model. And they have over 200,000 machines running WasmEdge and large language model. Just think about that. And I'll tell you what problems they are solving using this particular software at this moment. So the problem we are trying to solve is to run open source Gen AI models, including large language models, voice to text, text to voice, text to image, video to language models on your own infrastructure, or bundle it with your own applications, okay? So if this is not of interest to you, if all you want is to give your data and give your money to OpenAI, then I think the rest of the talk wouldn't be that interesting to you. But if this is what you want, then my next question to most people is that how do you run it, right? If you want to run large language model applications on your own infra, what tech stack do you use? And most people's answer is Python. Isn't that obvious? That's the large language model are all trained in Python, and they're PyTorch and everything. But I want to make a convincing case against Python. Why not Python? I don't want to be bad-mouthing about any of the technologies that I mentioned here, but I think it's important to mention some of those in order to say why we are different, right? So one of the biggest problems with Python is extremely bloated, and also when you do things like encoding, decoding, it's extremely slow. And it's not just me saying that. If you look at the Python's Docker image, the Docker image for PyTorch is 8 gigabytes, okay? 8 gigabytes of Docker image. Imagine running it on your edge devices like our users, running in the car, on Raspberry Pi, Orange Pi, and things like that. You need 8 gigabytes of disk space and memory to run it. So Python, in a lot of use cases, Python is not a good choice. Then if not Python, I think most people are using llama. I use llama too, running on my own computer. However, running it on the edge or running it on, say, on a production server, I don't feel this is the best choice, because one of the most important thing on llama is that it's llama, right? It's a large language model. So it has pretty weak support in terms of multi-modal models, like voice, like text and images, and things like that. But those are increasingly important for your application. So we're going to demonstrate, we're going to show some application like live translation and things like that. It's all the interaction modality is all video and audio, right? And another thing about it is that it has heavy operational support, meaning that it's a Go application. It contains multiple platform-specific binaries, so hundreds of megabytes, and it requires a daemon that requires pseudo permission running inside your container or on your machine, which is a little too heavy for me. So if not llama, then what about just go straight to the C++-based framework that underpins both Python and llama, like llama.cpp, whisper.cpp, VRM, and things like that. But those are the things that we go back to the cloud, before cloud native days, before Go language, before Rust language, right? We go all the way back to C++, which is also something we don't want. So that brings us to the framework that built on WasmEdge, is a WebAssembly framework written in Rust. We call it llama-edge. That's for obvious reasons. So the naming is not particularly innovative, but it provides out-of-box. It provides OpenAI compatible API servers. So if your application, your LangChain application, your Llama Index application is built to use OpenAI, you can just change api.openai.com to localhost 8080. That's it. You would be able to run those applications using your local model, right? So that's so here's the URL, and there's key features. Is the things that everything I talked about was other solutions are not, like lightweight, portable, wide selection for AI models, embeddable, and cloud native support in major distributions. So since we are CNCF projects, so we have supported upstream in a lot of Linux distributions and other distributions, right? So there's some agent use cases from the community I want to highlight. So, so we have things like, AI-written newsletter about all kinds of different topics. That's a newsletter. If you think about newsletter, someone wrote it and you receive it, right? But instead of that, someone come up with the material every day, and you receive something entirely different based on your preference, right? Agentic video translation, so that's a typical case of scaling inference instead of scaling the training, meaning that we take this video, for instance, from this KubeCon and feed that into a pipeline, and it's gonna have text, have voice to text, and have multiple agents to do the translation and check the translation quality based on the content that's being spoken at the event. And then, resynthesize into voice depending on the voice character that you choose, and then output video at the other end. So we have multiple, we have done this for a couple conferences for 100 hours of videos at this moment. Not us, but community that using our software, right? So there's encoding assistant. Obviously, there's with the new chairman coder model that was released yesterday, you have a truly state-of-the-art open source model that can do coding assistant. So my time's up. So if you are interested, we have several talks in this KubeCon. Just look us up: WasmEdge, llama.cpp, and if you go to our repository, like it, fork it, and contribute. Thank you.